Next, we have the inscribed angle theorem. This theorem states that if two inscribed angles intercept the same arcs, then the measure of the angles are congruent. So in the figure above, angles A and B are congruent because they intercept the highlighted arc. Let's try answering this example. Find angle A if angle B has a measure of 70 degrees. Well, since angle A and angle B share the intercepted arc of CD, then we can say that the measure of angle A is equal to measure of angle B. Therefore, the measure of angle A is 70 degrees. Number 2. Quadrilateral ABCD is inscribed in circle O with diagonal BD containing O. The measure of angle E is 30 degrees and the measure of arc AD is 80 degrees. Let's find the angles 1 through 6. Well, the measure of angle 1 is 90 degrees since the angle intercepts semicircle BCD. The measure of angle 2 is 40 degrees since it is half the measure of the intercepted arc AD. The measure of angle 3 is 30 degrees since it is an inscribed angle that shares the same intercepted arc with angle E. The measure of angle 4 is 90 degrees since the angle intercepts the semicircle DAB. The measure of angle 5 is 180 minus the measures of angle 3 and 4, giving it the measure of 60 degrees. And finally, the measure of angle 6 is 180 minus the measures of angle 1 and 2, giving it the measure of 50 degrees. Both of these were done by calculating the sum of the interior angles in a triangle. Next, we have the intersecting chords theorem. This theorem explains that when two chords intersect inside a circle, the product of the lengths of the line segments on each chord are equal. So in the figure above, AP times PB would equal CP times PD. Let's try to answer this example. Chords AC and BD intersect at point E. Find the measure of segment EC if AE equals 6, BE equals 10, and DE equals 9. While using the theorem, we can say that AE times EC equals BE times ED. This gives us 6x is equal to 10 times 9. When we solve for x, this gives us the answer of 15. Therefore, the measure of segment EC is equal to 15. Now let's try to find the value of x in the given figure below. While using the intersecting chords theorem, we can get the equation x times x minus 2 is equal to 12 times 4. Simplifying further, we get x squared minus 2x minus 48 equals 0, and when solving for the quadratic equation, we get the value of x, which is 8.